Let's say you are working for a streaming company like Netflix, Amazon Prime, or Disney Plus Hotstar, and your company is looking to purchase contract rights of some trending movies and TV series. The Marvel franchise looks lucrative. They've had a pretty good run at the box office with movies like Iron Man, Captain America, and Infinity War. The stakeholders come to you, the data engineer, and say, hey, can you get us some data on how these movies did at the box office? We want to analyze the performance of the movies, some revenue trends, viewer demand, and content performance. All to answer the question, is this a good enough investment? Well, in the real world setting, you will have a team of data engineers who will work on this problem. But let's say you are the Iron Man of the data world. You have to solve this problem by yourself. Have you ever wondered what happens on the inside of this decision-making process? Let's find out today. In this video, we're going to build a data ingestion pipeline that pulls data from multiple sources and stores it on a data lake. We're going to be building this data ingestion pipeline on AWS using services like AWS Lambda and S3 storage. This is part 1 of building an end-to-end data engineering pipeline on AWS, and in this video, we will be focusing on the data ingestion part, mainly pulling data from different sources like HTML, JSON, XML, and we will load this data into an S3 bucket in CSV format. This will be done using AWS Lambda, and we will schedule this using a CloudWatch trigger. With that said, let's get started. Hey there, if you're new here, I'm Sanchana and I'm a software data engineer, and I make videos on data engineering, AI, and everything in between. If you're looking to kickstart your data engineering journey, then follow me along and make sure you are subscribing to my channel. Now, let's jump into the video. First off, what is AWS? AWS is a cloud platform provided by Amazon. It offers a variety of cloud services from storage, compute, database management, machine learning, and the list goes on. What is AWS Lambda? AWS Lambda is a serverless compute that lets you run code without provisioning or managing servers. Now, what is S3? S3 stands for Simple Storage Service. It is a type of object storage on AWS. In object storage, the data is stored in a flat structure as opposed to the hierarchical table-like structure. This means that each object has its own unique ID and metadata. This allows for easy access and management of large amount of data. Because of this, it can hold any type of unstructured data, including files, images, videos, and datasets. Because of this, S3 is also called as a data lake. A data lake is a centralized storage system that keeps all the raw data from different unstructured formats in one place. That was a quick intro about AWS, AWS Lambda, and Amazon S3 buckets. Now let's get started with AWS. You can type AWS free tier and this will take you to the free tier sign up page. On the page, you will see that AWS offers several of its services in the free tier. The free tier allows you to work on AWS services for up to 1 year. As we can see, the S3 service is available to use for up to 5 GB, and the AWS Lambda service is available for 12 months, and there is a usage limit of up to 1 million requests. There are many other services that you can use as well in the free tier. If you want to use these services, then go ahead and create a free account on AWS. That is how you get started with working on AWS. Let's understand how we are going to build our ingestion pipeline. To build our data ingestion pipeline, we require 3 pieces of information. First, we require the list of all Marvel Universe movies. Then, using these movies, we require the characters and cast within each movie. And for each of these movies, we also require the rating and box office performance. As shown on the screen, this is the structure of our data ingestion pipeline. In order to get information about the Marvel movies, we will be using Wikipedia as a source. This is the web page that we will be using to extract all the Marvel Universe movies. The information for all of these movies is present in different phases. As we can see, the first phase is the Infinity Saga. There are 3 phases in the Infinity Saga. Phase 1, Phase 2 and Phase 3. Then there is also the Multiverse Saga, Phase 4, Phase 5 and Phase 6. And there are also future Marvel movies. Within each of these tables, there is information about the film name, release date, directors, screenwriters and producers. In the last two cases, there is also information about the status, which can be released, post-production, filming, in development, and so on. So in total, there are 7 tables where we can extract our information from. In addition to this, once we are able to get all the Marvel movies information, then we would require the cast and the characters for each of these movies. Luckily, this information is also present in the same Wikipedia page. If we scroll down, we'll see that there is information about the character, phase, and the character name, the first one being Hulk, and the cast name in each of the phases. So in phase 1, it was Edward Norton, and then came Mark Ruffalo, and he continued up till the end. So this will be our second table that we will be using to extract information from. Now, once we have the movies, characters and the cast, we would require the IMDb rating and box office revenue for each of these movies. For this, we will be using the OMDB API. The OMDB API, the Open Movie Database, is a free API that you can use to extract movie-related information. There is also additional information about how you can use this API. So let's say I type Iron Man and say search. This returns the output in JSON format with the title, year, release date, rate, runtime, plot, and so much other information. I can also change it to XML format and look for the same, and it returns all of this information as well. Now, to extract information from Wikipedia we will be using WebScraping and Beautiful Soup. And in order to extract information from the OMDB API, we will obtain a key from the OMDB website. Going back to the OMDB website, the key can be obtained by clicking on API key, clicking on the free 1000 daily limit. Then we can input our information, the email address, name and last name, and submit this form, and you will receive an API key to your email. After you obtain the movies in a data frame, characters and cast in another data frame, and ratings in a separate data frame. So we will have 3 data frames by the end of this extract process. Then we will use this function within AWS Lambda function and trigger a job to load this information into the S3 bucket. This information is stored in the S3 bucket in CSV format. We will also be performing some level of cleaning and transformation for the data that we obtain. That was about the design of our data ingestion pipeline. Now that we've understood how to build the pipeline, let's jump into the code and write our function. Now, you can open code editor. I'm using VS Code for this. What I will do first is create a virtual environment. Although this is not mandatory since we won't be using this editor, but I feel that creating a virtual environment always is beneficial in packaging all of the things that you're going to use in one place. So I've created a virtual environment named when, and now I'm going to activate it. Source when bin activate. This will now activate my virtual environment. Now let me create a Python file. I'm going to call it Marvel IPYNB, and let's first start with getting our movies from Wikipedia. First, let's import some libraries. So I'm going to import pandas request bs4 that we'll be using for web scraping, and re is the regex function. So let's install pandas request bs4. Now if we run this, we will know as to whether our packages have been installed or not. Yep, that ran successfully. Now the next step is to go to the Wikipedia page, which is list of Marvel Cinematic Universe films, and we have the URL here. So I'm going to copy this and paste it over here and load it inside a variable and call it URL. Now if we do the get method in order to get the response of this, we will see that, and then we will load the response into beautiful soup and then say soup. Once we execute that, we'll see that the HTML information is all present on the screen. So this is all of the HTML information from this web page. However, we only require tables of phase 1, phase 2, phase 3, phase 4, phase 5, phase 6 and future. So in total we require 7 tables. And to get this, let's just say, let me click on one of the tables and say inspect. This will take me to the body, and here we can see that the entire table is under the class called wiki table. So if we scroll down, we see all the tables have the class named wiki table. Whenever we hover on top of this, we'll be able to see the corresponding component highlighted on the left. So what we're going to do is we're going to go back and load and find all the tags named wiki table from soup, and we're going to be loading that into tables. Let's print this. Here we can see that we have film, US, release date, director, screenwriter and producer. Now we're going to be using a function to load all of this information from the tables and store it in a data frame. Just copy paste the function that I have here and put this out and run this. By now, if I say display df, I'll be able to see the future table, which is the final table. Now let me just put this back. I'll also add the phase information. We delete this. Phase related information is pasted here. And then I concatenate everything from all data into a movies df, and I say movies df. There we go. We have all the tables information loaded into this data frame. So there are up to 7 phases now. And if we say df.shape, so we say movies df.shape, we'll see that it has 44 rows and 7 columns. So there are 44 movies and 7 columns. All right. Now, what we observe here is that the release date is printed in 2 formats. The director has the citing at the end. There is writer information, and when it comes to the producer column, many of the values are null. So if we go back to the screen and look for phase 1, we see that the producer Kevin Feige has produced 4 movies: Iron Man, Thor, Captain America and Avengers, and all of them are, and basically these rows are merged into one. However, the code is not able to recognize that and it is printing it as none. So we'll have to perform a front fill operation for this. So let's start with that. Yeah, so now we see that after we perform the front fill operation, Kevin Feige is printed 4 times. The same issue persists with the status as well. So let's change that as well. And if we print this, we'll see that status related information is also printed distinctly. In addition to this, let's clean up the release date and remove the citing from the director column. So let's clean that up, and when we print this, now we have the release date in YYYYMMDD format, and there is no citing at the end of the director's name. Now, alright, so now let's just rename this to movies df. I'm gonna say movies df clean dot copy. Not the best way to do it, but let's just go on with it. And yep, now the movies df has all the Marvel movies related information that is present on the Wikipedia webpage. Now the second part of this is to get the characters and cast information. Going back to our web page, if we scroll down, we see the character and cast information. So I'm going to do the same thing, say inspect, and it brings us back to this table. But the difference over here is that there is a caption for this table named as recurring cast and characters of Marvel Cinematic Universe. Let me paste this function. It's same as before, only difference being we've filtered using the cast information, using the tag that we just found. Yeah, I'm gonna paste it here. I'm gonna call it characters df, and if we print it, we see that the characters along with the face related information is stored in characters df. So that was our second data frame. We are going to be using the OMDB API that we got on our email. So the third part of this is the OMDB API, and the way we use it is by, I'm going to be pasting my API key over here. I'm going to save it, and I'll be running this function. So now that I run this function, I can see the title, year, rated, release information along with IMDb rating, box office numbers, and so much other information. So let me just check result df. I'm gonna check the number of columns in this. So I'm going to say columns, and I see that there is also language, country, awards, poster, and all that information. So it's a pretty good API. I'm just gonna keep it the way it was. And yeah, with that we have 3 of the data frames that we need. Now what we're going to do is load all of this information into a Lambda function. But before that, let's go to AWS and see what we see and create our S3 bucket over there. We're on the AWS homepage, and on the dashboard we see a lot of information. But now we'll directly go to S3 and create our bucket. I'm going to say create bucket. I'm going to call this, it says bucket with the name, same name already exists. So this is one thing that you have to know about AWS. It requires you to create distinct bucket names within the same region. So I'm going to just change that to data bucket. Okay, I'm going to change it to movies AWS bucket. And I'm going to say create bucket. So yeah, this is our AWS bucket. Now that we've set up our bucket, let's come to AWS Lambda and let's create a function. I'm going to say create function. I'm going to call it movies function. Change the runtime to Python 3.9, use the ARM architecture, and create a function. So what we're going to do is delete this entire function and create a Lambda handler function here that we'll be copy pasting to our Lambda function. So I'm going to call it Lambda function.py, and when we open this, there are several steps that we can follow. The first one being scrape Marvel movies, clean movie data, fetch movie data from scrape characters data, and finally we also obtained the fetch movie data from OMDB API. So let me paste the individual functions that I've created for each. Before that, let me just import the libraries, and then I'm going to copy paste the two additional steps that we have to add over here is to upload the data frame to S3 and also define our Lambda handler function. So now that we have this, what we're going to do is copy this, paste it in here, and the last step that we're going to be doing over here is add a layer. This is because AWS inherently does not have these packages pre-installed, and these layers allow us to use existing packages within the AWS SDK. So we're going to be using add a layer, and once we add a layer, go back to our movie function, test, create a new test, save it. I'm going to say sample test, save it, deploy this function, then I'm going to test it, and we see an error. Go to configuration. I think there's a timeout error, so I'm gonna give the timeout as 15 seconds, and in the memory let me just change it to 1024 GB. So basically 1024 MB is 1 GB. Let's save it, go back to our code, now test it again, hopefully it works. It says access denied. One more thing to add, where we're supposed to go to IAM, create role, create a new role, and choose a service. In this case, we are going to choose Lambda. We give it administrator access, and then we give Lambda full access, and we also give S3 full access. Say next, and say we're going to create the role, and we're going to call this movies role. All right. And then let's say create the role, go back to our S3 bucket, within functions, go back to our S3 bucket, go to configuration, say edit configuration 1024, and change this to movies role and save it. Now let's try running our code, and hopefully first let's deploy it and then run it. Alright, So we got some exceptions, but we received a response to 100, so our data is successfully uploaded to the bucket. Yay. So let's go to our S3 bucket, AWS bucket, and we see our character, movies, and OMDB CSV placed over here. We successfully built our data ingestion pipeline, but one additional thing that is left to do is to schedule our Lambda function. So let's say we'll add a trigger and we're going to say EventBridge, and we create a new rule, and let's say we're going to trigger this every day, and the rule name is movie trigger. Ideally, we do not need it for every day, but this is just for the sake of an example that I'm showing you. We add the trigger, and here we'll see that the EventBridge is going to monitor our movies Lambda function. And that's how you can schedule Lambda functions. So that was it. We've successfully built our data ingestion pipeline that extracts information from different sources and stores it in an S3 bucket using a Lambda function. Hope you enjoyed part 1 of Build a Data Pipeline on AWS series. I'll be adding more components to this ingestion pipeline. Namely, we'll use the information that we've stored in our S3 bucket, transform it, and load it into a data warehouse and do some visualization in the upcoming videos. So if that sounds interesting to you, then make sure to subscribe to this channel, and I'll see you in the next one. Bye.